All right, today we're going to talk about cube roots. So would you please jot down? We're going to turn it into a cube. So what I need you to do is, just like we did the other day, draw a square freehand, and then go ahead and put those markings on that indicate that it's a square, please. Okay? Now I'm going to show you a trick to turn this square into a cube. All math geeks know this. You start up here and you draw a little segment shooting out of that corner. Then you come down here and you draw another segment exactly the same length and parallel to the first one. And then you come over here to this corner and you draw another segment exactly the same length and parallel. So all three of these are shooting in exactly the same direction. They're parallel and they're all the same length. Then all you have to do is connect these. And you'll create the optical right angles everywhere. So every place that you can see an edge or an angle, we want to mark it as such. All right, so we have created the all-famous cube. All right, now back in elementary school, usually around 5th or 6th grade, they teach you how to find volume. Does anybody remember? Maybe you'll remember. Length times width times height. Do you guys remember that? Every single one of these edges is the same length, and the other day we called them S. Why did we use the lowercase cursive? Right. So we're going to have an S here and an S here. All these edges will be S. Well, by George, if I substitute in these S's for the length, the width, and the height, I'm going to have S times S times S. All right, now you can give this to me as an exponent. Nick?
S cubed.
Yes, it's S cubed, or S to the third power. Now, when you say S cubed, okay, the first column is S, and the second column is S to the third power. And I'd like you in parentheses to please call that perfect cubes. The other chart we had 4, 5, and 10. In my adult life, we're looking at 1 times 1 times 1, which is, everybody? 3. No, it's not 3. It's 1. Most common mistake is 2 times 2, which is, everybody? 8. Good. You didn't say 6. Next one is 3 times 3 times 3. It's not 9. 27. Yeah. Now this is one. 4 times 4 is 16, and then times 4 again is 32.
64.
No, it's 64. Yeah. That one always gave me trouble. But this one, the 5 is easy. You just think quarters. 5 times 5 is 25, or 1/4, right? And if you take that times another 5, if you have 5 quarters in your palm, how much money do you have? $1.25, right? So whenever you're trying to multiply, all right, now this, of course, is 10 times 10 times 10, big number. Anybody? 1,000, right? So those are, we want to talk about what will undo this cubing. A square root will undo squaring. It's a 3 that is sitting on the seat of a square root sign. Go ahead and try and draw 1 or 2 or 3. If I put 125 here, what I am really asking is what number times itself and then times itself again is equal to 125. And so go ahead, what's the question mark equal to? 5. Right. So the cube root of 125 is 5. All right, what is the cube of 8? What number times itself gives you 8? Nick?
2.
Good. How about the cube? Okay. Would you all please take 1.5 and hit your power key if it looks like that, or y to the x. Take it to the third power, and then raise your hand. Good. How about the cube root? Cube root of 3. Okay, all right. That means there's some number out there that if I take it times itself and then times itself again, I'm going to get 3. Now, I don't want you to yell out. I really would like 3.375. All right, so it's a little bit too big. Next suggestion. 0.5? 0.5? Okay, let's all try 0.5 to the third power. And what do we get there? That might surprise you. I know it surprised me. What did you get?
0.125.
0.125. Yeah, that's not even as big as 1. So our answer has to be somewhere in between here. Next. All right, let's try 1.2 to the third power. Dylan, what'd you get? I have to record it. Who has 1.2? Go ahead, Jesse.
1.728.
1.728. Did anybody else get that for 1.2? Yeah. What?
1.4.
All right, let's see if 1.4 will get us up into the, like 2.9s. Okay, what do we get? Jesse, what'd you get?
2.744.
2.744. Is it stop there?
Yeah.
We need to find a number between, make sure you're getting this, Matt, 1.4 and 1.5.
1.45.
Are you yelling? Jesse?
1.45.
1.45. All right, let's try it. 1.45.
Goal.
To the third power. Dylan, what'd you get? 3.04 what? 625. Okay, we have 3.0. We're getting close. All right, so that'd be 1.44. And Nate is 0.125. All right, so we're down 125. Woo! We'll take it out here to 100,000s here and see what we got. To the third power. Do we have three of us?
What is that like?
9 what? You gotta say it slower. But it has to be smaller than 44250.
Okay, you can see that what's happening here is we are getting closer and closer. And if we continue this, we'll get closer and closer to 3, but we're never going to quite reach 3 because the cube root of 3 is an irrational number. It's a decimal that goes on forever. It never stops. It never repeats. It's an irrational number.